Lesson 4. This unit is a Unit 2 review. So we're just going to review everything from this unit. And then we'll go on from there. So the objectives for this unit is I can know the difference between lossy and lossless compression. I can explain the Lempel-Zev-Welch algorithm and text compression. That was, if y'all remember, was lesson 2 in the unit, text compression. And then I can explain the run length encoding, or REL, image compression algorithm. That was the last lesson we took. So let's first look at lossy versus lossless compression. Now, lossy versus lossless compression is a pretty simple idea, right? Lossy is it gets rid of data, while lossless can be recreated. It compresses without losing any quality or without losing data, but it does save space. Let's look at some of the differences. So, lossy versus lossless compression. Lossy compression algorithms reduce the size of files by discarding the less important information in the file, which is what causes the loss in quality, which this is used to significantly reduce the file size, but definitely affects file quality. This is lossy. Remember, lossy, you lose information, so your file quality is going to be, you're going to lose quality as well. This type of information helps save a lot of space, but the quality is kind of lost because we're getting rid of information, and it can't be undone, which is why people really don't like lossy compression. Now we go back to lossless compression. Lossless compression algorithms reduce the size of files without losing any information in the file, which means that we can reconstruct the original file, the original data from the compressed file. This kind of compression algorithm saves space and a lot of info, and the quality doesn't change, but it doesn't save a lot, like you don't lose any information. So everyone uses this kind of compression, so this kind of compression is the preferred compression type, lossless. And the two algorithms we talked about in the last lessons, the run length encoding and the Lempel-Zev-Welch algorithm, are both lossless. And it can be undone. You can compress and uncompress files as many times as you want. Yeah. Keep that in mind. Remember, this is just review from the unit. So once we start digging, after looking at lossless versus lossy compression, we look at the Lempel-Zev-Welch, or LZW, the text compression algorithm. Now, this was the text compression algorithm from lesson 2 of this unit. And if you remember, this is the one where we had the cool activity. Yeah. So let's look at that particular compression algorithm. Here we go. Text compression. Text compression. Computers can compress text by finding repeated sequences and reducing them with shorter representations, and then adding a dictionary to the end of the file. This is now, if you'll remember, this was like from our example, we took like great and then 8s, and we turned them into like the number 8 and the letter great, GR8 as well. If you remember from last lesson, or 2 lessons ago, this was text compression. So the idea here is we find repeated sequences of stuff, characters, and then we replace them with shorter representation, and then we obviously have to always remember to add a dictionary to the end of the file. Obviously, this is a lossless form of compression, which means we don't lose any information because you can always reconstruct whatever data you compressed, using this algorithm. You can always reconstruct it as long as you know that you have the dictionary. And you don't lose any information by compressing text this way. Yeah, that's text compression. Now, as we move into the further parts of the later parts, the image compression, run length encoding, if y'all remember, run length encoding was where we had that bitmap image, and this was last lesson where we had the bitmap image, and we were taking the particular bitmap image and looking at repeated sequences and things. So we were looking at repeated pixels. We changed, if it had 2 white repeating pixels, we changed it to 1. If it had 2 white, we just remembered how many times the white pixels repeated and how many times the colored pixels repeated. And that was called run length encoding, and this was image compression. You can look at the last lesson for details. Run length encoding compression. In run length encoding, RLE, the computer replaces each row of a bitmap with the numbers that say how many consecutive pixels are the same color, always starting with white. With the number of white pixels. So we always start with the number of white pixels. It finds things that repeats, and it tells us how many times they repeat. For example, let's say a row containing 3 white pixels, 2 red pixels, 5 white pixels, and 2 red pixels, and 4 white pixels would be represented something like this, right? 3 white pixels, 2 red pixels, or 2 colored pixels, 5 white, 2 colored pixels, 4 white pixels would be represented by 3. We just remember 3, 2, 5, 2, 4, which is a much smaller to remember, much smaller to remember file size. And remember, these may seem, not very useful at shorter spans, but with larger and larger images and bitmaps, these obviously are super useful in that they can make the file size quite small. And now here we conclusion. So for this unit review, I know this is a quick review here, but we reviewed data compression. This was the data compression unit. Basically what you need to know is what is lossy versus lossless compression. Again, let's talk through this again. Lossy compression loses information, whereas lossless compression doesn't lose information. Both compress the data quite a bit, but lossy compression, we lose the information and we can't get it back. But lossless, we don't lose the information and we can easily recover it. Okay, what is the Lempel-Ziv-Welch, or the LZW algorithm? That algorithm we use for text compression. It is a pretty interesting algorithm we use for text compression, in that it finds repeated patterns. For example, like if th, or if like the word 8, like in great, or 8s, or things like that, if they repeat like th and the, th and thing, when it repeats, it basically will find repeating patterns and replace them with shorter characters, and then at the end of the file it'll save a dictionary of like which characters are replaced and which characters and to what characters they map, right? So it'll save th and then the symbol that we mapped it to. Again, this is just review from the last lessons, 2 lessons ago. Lempel-Ziv-Welch, LZW, this goes with text compression. And then what is run length encoding? What is that? What is the run length encoding compression algorithm? Well, the run length encoding compression algorithm is the algorithm, right? Like the the image compression algorithm that we looked at last class, where if you have a bitmap of sorts, it will pick up on, it'll go row by row, starting with white pixels. It'll tell us how many white pixels we have and how many different colored pixels we have. The example we used last class was white and red, but it doesn't really have to be white and red. It's really just an image compressing tool. Yeah, and then important algorithms to remember for this unit were obviously the run length encoding algorithm and the Lempel-Zev-Welch algorithm. Again, run length encoding is image compression, and Lempel-Zev-Welch is the text compression algorithm. Yeah, that's pretty much it for this unit, but I just wanted to review, make sure y'all understood everything before testing y'all. Yeah, I hope y'all enjoyed this quick review, but I feel like we should probably I hope y'all enjoyed the quick review. Just thought I'd upload it, make it easier for y'all to do it. Thank y'all for listening. And be sure to subscribe to the YouTube channel and like the video if you enjoyed it. And tell me if you like this format better. Yeah. Have a nice day, y'all. Bye.